All right. So if we're looking for all the zeros of a polynomial, think back to section 3.4. I know it's been a while, right? But that's what you're actually doing in the homework that's due tonight. So what would be our first step if we're looking for the zeros of that polynomial? Awesome. P's and Q's, right? So this is where we're going to identify the P values and the Q values. And so if we're looking for our values of P this time, how are we going to find values of P? Good. So we look at the factors of the constant, which in this case is that -3 at the end. So what would be our factors of -3? Awesome. So we have plus or minus 1, and we have plus or minus 3. So just remember, it's always going to be positive and negative values of each of those, right? And the only factors of 3 are 1 and 3. So we have plus or minus 1, plus or minus 3. Now we want to identify the Q values for this one. So how do we find the values of Q? Good. 1 and -1 because it's the factors of 1. So remember, we look at our leading coefficient. In this case, that's an understood 1 in front of the x cubed. So we're just going to get +1 and -1 as our factors for Q. Now, once we have our P's and Q's, remember we need to divide. So when we do P divided by Q, we're going to take each one of our P values and divide it by each one of our Q values. So what would that give us as P over N? Good, right? So it's actually going to be the same as our list of P this time. When we divide each of those by 1, we're still just going to get plus or minus 1 and plus or minus 3. So those are our values. Now, once we have those, remember there's 4 values here, 1, -1, 3, and -3. What are we going to do next to determine which ones we actually want to test? All right, so we are going to use synthetic division to test, but if we don't want to test every single value, what could we do first to see which ones we even want to look at? We can graph. Good. All right, so that's what I'm going to do now. I'm going to go into Desmos. I'm going to graph this, and then I'll try to share that graph so everybody can see it together. So we've got y equals x cubed. Right, and feel free to graph this with me too if you want to graph it in Desmos yourself, or if you've got a graph calculator sitting there with you. And I will try to share this screen so we can all see it. And so there is our Desmos graph. So if we're looking at that now, what value does it look like we might want to test in this case? Good, right? So it looks like the graph goes through +3. So that's the one I'm going to test this time. And notice here, it doesn't look like we have any other x-intercepts. So that's the only value I'm actually going to be able to test using synthetic division, right? So let's try that. So I'm going to go back to my other screen here. All right, and so if we do our synthetic division now, remember we've got our 3 in the box, and then we're going to list out our coefficients here. So we've got x cubed, x squared, x, and then no x at all. So we're not missing any terms. So that's just going to be +1, -3, +1, and -3. Again, first step, bring down that first term. So that gives us a 1. Then we can multiply. So we do 1 times 3. That's going to give us +3 here. -3 plus 3 is going to give us 0. 0 times 3 is 0. 1 plus 0 is 1. And then 1 times 3 is going to be +3. And when we add those together, our remainder should be 0 this time. All right, now once we do that, now we've got to think about what this line down here actually tells us. Okay, so we started with x cubed, we divided out an x, right? Because we got one of our zeros that works because we got a remainder of 0. So what is this line, the 1, 0, 1, what does that tell us? Good, right? So this one is the coefficient of our x squared term. We have no x term because of the 0, and then this is just going to be plus 1. So now, what would be our factors that we have so far? Sorry, let me make sure that's coming back up there. All right, good. So x minus 3 and then x squared plus 1 would be our factors. That come back into focus. Good. So now we have x minus 3, and that comes from the fact that 3 was one of our zeros. And then we're also left with this x squared plus 1 here that we got at the bottom. Okay. Now, at that point, we know that 3 works, but we still have this factor down here. And so what could we do with that to find the rest of the zeros that we're going to have here? Yeah. So, German, if you want to turn your mic on, that's fine.
You can set the whole thing equal to 0.
Good. We're going to set the factor to 0. And Naomi, you said quadratic formula. Quadratic formula works. In this case, because it's a simple quadratic, right, just an x squared and a number, we can actually solve this a little bit easier without having to use the whole quadratic formula, though. Okay, but yes, quadratic formula would work, right? It's just a little bit more than we need. So if I have just x squared plus 1 equals 0, what would I do to solve that? Okay, good. Subtract 1, so that gives us x squared equals negative 1. And so then we would have to do what? Take the square root. Perfect. And if I take the square root of both sides, that's going to give us our x. What are we going to have on the right-hand side now? Good. The square root of 1 is I. And what else do we have to remember, though? All right, good. So Kenneth, it would be I times the square root of 1, and then the square root of 1 is just 1, right? And so that's how we're just going to get 1I here. But anytime you take a square root in an equation like this, what else do we have to remember? Plus or minus. Good. So this is going to be positive I or negative I. Those are going to be our other two zeros in this case. So if we're just listing out all the zeros for this one, we're going to have positive 3, we're going to have positive I, and we're going to have negative I. So those would be the 3 zeros of that polynomial function. So as you can see, the steps are still pretty much the same as what we did in 3.4 before break. It's just that now we have these complex numbers that we can use, and so some of these functions are actually going to have imaginary zeros. Now, in terms of the complete factorization of this, once we know all of our zeros, now we actually want to write all of the factors that we would get from those zeros. So what would be the factor that we would have from the 3 here? X minus 3, good. Now, what would be the factor that we would use for the I? Just take a guess if you're not 100% sure. So use x minus 3, almost, right? So in this case, to get the positive I, though, we would actually want to make this x minus I instead. Okay. All right. Your screen froze. Are we back together now? Good. Okay. All right. So yeah, so in this case, right, this positive I right here, we can use the factor x minus I, and that'll actually give us that as one of our zeros. And so then what would our last factor have to be to give us a negative I then? Perfect. X plus I. So that's going to be our complete factorization for that problem now is x minus 3, x minus I, and x plus I, since these three things right here are the zeros. Okay. So any questions on how we got any of that now? All right. Does anybody need more time to write any of that stuff down now? And again, if you ever do, if I ask that question, just click the raise my hand, and that'll tell me you need a little bit more time. All right, if we're good, let's move on to example 2. All right, so same thing, we're trying to find all the zeros, and then we're going to find the complete factorization. So I'll give you a chance to write down the polynomial. All right, so what's our first step here? P's and Q's, good. So let's go with our P values first. So what are going to be the values of P this time? Minus 1, 2, and 4, good. So plus or minus 1, plus or minus 2, and plus or minus 4. And then for our Q values this time, what are we going to get? Just positive 1 and negative 1, good. Which means that P over Q is just going to be what? Same as the P's, right? So plus or minus 1, plus or minus 2, and minus 4. Good. All right, so just like before, now we can look at our graph to see which ones of those we might actually want to test, right? So again, I'm going to go into Desmos and I will graph this one. I'll share that screen. All right. So which one does it look like we want to test this time? Good. So negative 2, value we're going to test. So that's what's going to go in our box. Switch this back over now. All right, so now when we list out our coefficients here, what are the coefficients going to be for this one? Good. Just because there is no x squared term, right, we're going to actually have to put a 0 in that place. So we're going to have 1, 0, negative 2, positive 4. And bring down the 1. Now we can multiply. 1 times negative 2 should give us negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2, positive 4. Negative 2 plus 4, positive 2. And 2 times negative 2, negative 4. Remainder of 0. Okay. Now, once we get to that line, what does this line tell us then? Good. X squared minus 2x plus 2. X squared minus 2x plus 2 is what we have from these coefficients here. So now, if we think about this, we could try factoring it to see if we can find the other two zeros, but I'll go ahead and tell you in this case, the factors of 2 are only 2 and 1. That's never going to give us this negative 2x that we want here. So at this point, what are we going to have to do to find the other two zeros that would come from that? Good. This time we do have to use quadratic formula. Since it doesn't factor and it's not a simple quadratic where we can just set it equal to 0 and move the number over, we're going to have to use quadratic formula to solve this one. Okay, so I'm actually going to come down here. I know this is under the complete factorization part. And I'm going to do my quadratic formula down here now. Remember, that's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. So what's our b value this time? Good. So when we plug that in here, right, we have a negative 2, so that turns into a positive 2, plus or minus the square root of b again is negative 2 squared minus 4 times, what's the a value? 1. The c value is positive 2. Good. All over 2 times a, so that's just 2 times 1. All right. Now we need to simplify. All right, so if we go through and simplify this, that's going to give us 2 or minus the square root of negative 2 squared becomes a positive 4. Then we have minus 4 times 1 times 2. That's going to become a negative 8. So we're subtracting 8 all over 2 times 1, which is just 2. Okay. Now from there, we simplify what's inside the square root. So we've got 2 plus or minus the square root of 4 minus 8 is negative 4 all over 2. And if we take the square root of negative 4, what should that give us? Good. So this is going to be 2 plus or minus 2i all over 2. And then remember, we can actually take each of these terms and divide by the 2 now. So when we do that, what's that going to simplify to? Good. 1 plus I, because 2 divided by 2 is 1, plus or minus 2i divided by 2 is just an I now. Okay. So now, if I want to know all the zeros of this, I'll come back up here and list them all out. What's one of the zeros, or if you just want to list all of them, what are all of the zeros of that polynomial now? Good. So we have 1 plus I, we have 1 minus I, and we have the negative 2 that we found over here because we said that one checked out. So that's our list of zeros. And now if we want the complete factorization, let's start our factor down here. What's the first factor that we're going to get just from the negative 2? X plus 2. Good. And so we know that's one of our factors. Now, if I want the factor that comes from the 1 plus I, so think about it this way. If we have a negative 2, all we're doing is we're changing the sign, and that gives us x plus 2. So when I do this, I'm still going to start with an x. And because I have multiple terms here, I just want to make sure that I change all of the signs that I have. So if I change all of the signs here, what's that going to give us down here then? Good. We have x minus 1 minus I as the next factor. And then the last factor, we're going to do the same thing. We're going to change all of the signs to this 0, and that would give us what? Almost. Okay, so in this case, though, the 1 is still a positive. So when we change its sign, it becomes negative. So it's really going to be what? There you go. X minus 1 plus I. Okay. So notice here, both of these are minus 1 because both of these were positive ones. It's only the I that's going to change sign. So here it's a minus and here it's a plus. Okay? No worries. Everybody good with that? Any questions on why that is the factored form now? All right. Does anybody need more time to get that written down? All right. Now, Zero's theorem. So for every polynomial that has a degree greater than or equal to 1, so we're just basically saying all of our polynomials that we've looked at, whether it's x to the first power, x to the fifth power, it doesn't matter, has exactly n zeros, meaning that whatever the exponent happens to be, whatever that degree is, that's how many zeros you should end up with. As long as we count zeros that have a multiplicity that many times. So let's say we've got one of our zeros that happens 3 times. We just have to make sure we're counting that 0 3 times in this number up here. That's all. Okay? So if you look at your degree, your highest exponent, that's going to tell you how many zeros you should end up with in your final answer. Okay? So that's just a quick check to make sure we found them all, is if we know the degree, we know how many zeros we're looking for. Okay? Again, I'm not going to take a ton of time on these types of slides just because I know they are provided. You can go back and look at them if you need to. So let's focus on the example here. So we want to find the complete factorization and all 5 zeros of this polynomial. Okay, so if we take a look at this one, what do you think we're going to do first? Okay, so Kenneth said P's and Q's. P's and Q's is what you would do. Why can we not do P's and Q's on this one to begin with? No constant, exactly, right? So because there's no constant term, we don't have a way to find any p-values, right? Okay, and Sarah said look at the degree, and that's absolutely correct, right? So we at least know how many zeros we're going to have. We know the degree is 5, therefore we're going to end up with 5 zeros. Now, since we don't have a constant to do our p's and q's, though, what do you think we might be able to do first with this one?
You could I don't know what the procedure is called, but you could take out an x from each thing.
Good, right? So look at the factor, right? And so
Yeah.
if I do that, so we have p of x equals, so we know we have an x in common with all of these. Is there anything else that all 3 of those terms have in common? A common factor. 3, right? So 3 actually goes into all of those numbers. So I'm actually going to factor out a 3x this time. Right? Now, if we do that, here this is factored out. One of the x's is factored out, so that's going to leave us with x to the 4th. If I factor out a 3x from this term, it can give us an 8x squared. And then a 3 from this last term down here is going to be plus 16, just like that. Okay. Okay. Now, looking at what we have left, right? We have this x to the fourth plus 8x squared plus 16. What do you think we could try to do with that now? Could do p's and q's, right? That's one option. Does anybody see anything else we could do with that one that might keep us from having to do all the p's and q's and the synthetic division? Could try factoring it, right? So since we have a trinomial here, this thing might actually factor. So let's see if it'll work. I'm going to try to put this into two binomials. So what would I start with if I want to get an x to the fourth power? Good. So x squared and an x squared. X times x squared would give us x to the fourth, right? So in this case, you're going to want the exact same thing in both, right? Because otherwise it's not going to give us the middle term that we want here, right? Even though x cubed and x could work to give us x to the fourth, since we know we want an x squared there, that's why we're choosing x squared and x squared, okay? Now I'm going to look down here at the factors of 16. So what would those factors be? Good. And in this case, it's going to be positive 4 and positive 4. It's actually going to be the same values in both, right? Because now that's going to give me a positive 4x squared, and another positive 4x squared is the 8x squared in the middle, and the 4 times 4 is the 16. So now this is the factored form of what we had up top. Okay. Now, once we have those factors, now if I'm looking for all 5 zeros, what can I do? Set them equal to 0. Good. So my first factor here is 3x equals 0. And I'm going to take the x squared plus 4, set it equal to 0. And then I'm going to take this other x squared plus 4 and set it equal to 0. Now, if we solve this first equation, 3x equals 0, what's our x going to be equal to? Okay, so not quite, because if I divide by 3 sides here, right, 0 divided by 3 is just going to be what? And Kenneth's got it, right? So x equals 0. Just remember, since I already have a 0 on the other side, if I just divide by 3, right, that's just going to give us 0. Now, what about the second equation here then? What could I do? It is going to be 2i, right? So we're going to subtract the 4. So x squared equals negative 4. And then we take the square root of both sides. And it is going to be plus or minus. Good, Naomi. So we've got x equals plus or minus 2i once I solve that. Now, notice over here, this is the exact same factor that we just got here. So all that's going to happen is we're going to get those same 2 zeros, plus or minus 2i, when we do that one also. Sorry, it looks like it got a little blurry. Hopefully it's coming back. Okay, so now we've got 0, plus or minus 2i, and then plus or minus 2i again. So if I want to just list out all of my zeros for this one, what's that list going to look like? Good. So we have 0, 2i, negative 2i, and then we have another 2i and another negative 2i. So notice here, 1, 2, 3, 4, 5 total zeros, even though some of them are twice, right? When we list them out, okay, you're actually going to have 5 total. So that takes care of the zeros part, and it also asks for the complete factorization. So now we need to list out all of the factors. So what's one of our factors going to be this time? Okay, good. Now, in this case, we have to be careful because technically it wasn't just x that gave us that 0. It was this factor of 3x. So I'm going to have to use 3x as one of my factors. And the reason for that is if I just use an x, I'm not going to get this coefficient that I want out front here. So just make sure we're using that as the factor that gave us that 0 there. Okay. Now, what would my next factor be? X minus 2i. Good. What would be another factor? X plus 2i. We should have 5 total, right? So the next one's going to be, and then repeated that, right? So x minus 2i and x plus 2i again. Now, because we have those repeated factors, how else could I write that instead? Good. So I could just say this is x minus 2i squared, and then x plus 2i squared. And so this down here now would be our complete factorization for this one, and then our list of zeros, all 5 of them are over here. Now, on a test, I'm fine if you just write 0 and then plus or minus 2i, right? That's all the zeros technically. Just know in WebAssign, when it asks for repetitions, you're actually going to have to list out all 5 of those individually. Okay, so that's why I do it that way there. Any questions on that one now? All right. Anybody need more time to get that one? All right. Now we're going to work backwards. Okay, so they're actually listing out what the degree is and what all of our zeros are, and we're going to see if we can actually find the polynomial from that. Now, I'm going to go ahead and tell you, let's just ignore this information down here because I'm never going to ask you to do that. So I'd rather just focus on being able to find a polynomial degree 4 that has those zeros. So let's just do that. All right, so if we know the zeros, what could we do with that information to help us actually find our polynomial? Good. So we can list out the factors, right? And so we know if I is one of our zeros, that means that x minus I is one of our factors. This is going to give us x plus I as a factor. Then we know that x minus 2 is a factor. And x plus 2 has to be a factor. And so that's our first step, is if we know the zeros, then we can just list out all of the factors. Now, once we have the factors, now we need to actually multiply them out to get our polynomial of degree 4. So always multiply the ones that have the i's first, because a lot of times stuff is going to cancel out when you do that. So I would just say at least do that first. Then we can go over here and multiply the x minus 2 and x plus 2. And we'll have those, then we can multiply all that together. So if we do x minus I times x plus I, what are we going to get? Good, right? So we're going to end up with x squared, and I'm going to write all the terms in here, even though they're going to cancel out, right? So plus xi minus xi, and then minus I squared. Okay, and then like Kenneth said, this positive xi and negative xi are just going to cancel anyway. Okay. All right, now I'm going to go ahead and do the x minus 2 and x plus 2. So if we multiply all that out, what are we going to get? Good. So x squared, and again, I'm going to write these out, and then I'll show that they cancel. So plus 2x minus 2x, and then minus 4, positive 2x, and negative 2x cancel out, so we're just left with x squared minus 4 there. Now, what can we do to simplify this before we start multiplying these two things together? If we factor, it's going to take us right back to what we started with, right? And so we actually do want to be able to multiply these together, but there's a value in there that we can change first before we start to multiply. So what can we actually change in there? That's right. So this I squared becomes what? Negative 1. Good. So this is going to be x squared minus negative 1, and then we have x squared minus 4. Okay. Now, since this was subtraction of that negative 1, this is actually going to turn into a plus. So we end up with x squared plus 1 times x squared minus 4. Now we need to multiply that out. So now we can use FOIL again because we just have two terms here and two terms here. So if we would multiply that out, what should we end up with? Okay, so we got x to the fourth. Our outer terms here are negative 4x squared and then plus 1x squared. All right, so let's make sure I'm going to write those out so we can see it, and then we'll combine like terms. We get a negative 4x squared plus x squared, and then we do have a minus 4 at the end here. Now, if we combine our like terms in the middle, what should that give us? That's right. So this is going to be a negative 3x squared. So we have x to the fourth minus 3x squared minus 4. So there is our polynomial of degree 4 that would have those zeros that we started with. Any questions on that one now? Okay, let's look at the second one down here. So now we're looking for a polynomial, q of x, has a degree of 4 again. Our zeros are negative 2 and 0, and negative 2 is a zero multiplicity 3. So again, we're going to start with our factors, just like we did on the first one. So what would be the factors of this one then? Good, right? So we know that x plus 2 is going to happen 3 times. So we're going to have an x plus 2 to the third power. We should have a degree of 4, so we still need something else in there. So what's the other factor going to be? Okay, 0 is the 0, right? So what would be the factor we use that would give us 0? Good. So we just need an x this time. So here's the factor that gives us the 0. Here's the factor that gives us the negative, and that should happen 3 times. Now we need to multiply this out just like we did before. So instead of writing this as x plus 2 to the third power, I'm actually going to list it out 3 times so that we can multiply it. So we've got our x plus 2, x plus 2, x plus 2. Now the order here doesn't matter, right? You can multiply any of these together that you want. I'm going to start by just distributing this x into this set of parentheses here. So that's going to give us x squared plus 2x. And then I'm going to go ahead and multiply these two down here together. So that's going to be x squared plus 2x plus 2x plus 4. And at that point, I can go ahead and combine my like terms in the second set. So we've got x squared plus 2x times x squared plus 4x plus 4. Now, it's up to you, right, how you multiply this. If you're okay with just distributing each of those to all of your terms, feel free to do that. I'm going to set up the box, right, so we can actually multiply everything together here, just to make sure we don't miss anything. So I'm going to put my x squared, my 4x, and my 4 across the top. I'm going to put my x squared, my 2x down the side here. So now when we multiply, x squared and x squared should be x to the 4th. X squared times 4x, it's 4x cubed. X squared and 4, 4x squared. 2x and x squared, 2x cubed. 2x and 4x, 8x squared. 2x and 4, 8x. We just have to make sure we combine like terms here. So I have these cubed terms there that I can combine, and these squared terms here that I can combine. So that leaves me with x to the 4th. That's going to be a 6x cubed. This is going to give us 12x squared, and then 8x. Okay. And so then that would be our final answer for our polynomial. It has a degree of 4, and that should have all the zeros that we wanted to get there. Any questions on that one now? Anybody need more time to get any of that? All right. I think we'll stop there because I don't want to rush through the next one. I think 3 minutes probably isn't quite enough time to get through it. So we'll start with example 5 tomorrow. Any questions, comments, concerns, anything like that right now, or anything that you feel like could be done better? Okay, now that we've met a couple of times, any suggestions? If you have anything, just let me know. So Naomi, the homework 3.3 and 3.4 is due by midnight tonight. Okay, so not that one. The next one is due the 30th, which is, I believe, let's see, today's the 25th, so that would be Monday of next week right now. And again, that's tentative, okay, but for right now, you got at least through the weekend to get that one done. Any other questions? All right. Well, I'll hang out just a couple more minutes just in case you do think of anything. Otherwise, you're free to go. And have a good afternoon, and I will see you tomorrow.